Well, hello everybody, and welcome to live stream six, number six of Rose Racer game development. So we've actually made a lot of progress this last week, and we're about to have a serious explosion of changes to the game visually speaking. We have several. We actually have three modelers working with us now that are all cranking on getting different aspects of the game modeled in 3D. And then our concept artist is working on some really amazing pieces to really bring the game to that, like, bring the game's vision to life, and kind of capturing that vision for the game. So we're super excited about that. So really quick before we get into today's live stream, which will be a little different, um, and I'll show you why it's going to be a little different in a minute. But really quick, always ask. It's super helpful to us to be able to connect with our fans and um, to have people know about the game, right? To get the word out there so that people know about Rose Racer. So if you could follow us on Twitter at Rose Racer Game, like us on Facebook at facebook.com/Rose Racer Game. And you can find more information about the game at the game's website, nacelgames.com/Rose Racer. And if you're watching this on Twitch, down below there's a follow button. You can follow us here on Twitch to let us know when we're live streaming, or to let you know when we're live streaming, and that'll let us kind of have an idea of who's being able to follow us live here on Twitch. And if you're watching on YouTube, because these videos will be archived over to YouTube, these live streams, there's also a follow button, or a subscribe button rather, below. Go ahead and click on that and be subscribed to our YouTube channel. That way you can know when we post videos to YouTube, not just live stream videos, but any other videos that we'll be posting up over the next several weeks. So today's live stream, like I said, is going to be a little different. And that is, we're actually in some code now. So we're to the point where we're starting to implement a lot of the core key systems that are going to be in use. So, as the lead programmer, I'm actually in the system, in the game, um, um, doing the gameplay systems. I'm actually doing some things in C++. So most of the stuff I'm doing in C++ now ends up being kind of heavier math calculations. So the cool thing about that is we get to see some C++ code. You guys will get to see that. But the other thing is that it does kind of change the workflow working with the editor. So I'm in what's called debug game editor mode, is the basically the build settings. So now when I actually want to run Rose Racer, I need to actually go and start a new instance of the editor out of Visual Studio, and that'll start a new editor instance. So it's going to sit here for a second and compile all the code. So that'll be a little bit more of the workflow now, is going in here, starting it to start building the code out, um, and loading all the symbols, and then it'll launch the game. So what I'm working on now is I'd already implemented a version of the system, but I'm actually revamping how it's working because it wasn't accurate enough the first time around. So the system I'm working on is, you'll probably recall, I think it was last week's stream, that I had initially set up this guy. So it's basically a spline that goes around the entire track, and what I'm doing is I'm able to use this spline plus a vehicle's location to be able to see and know, to be able to know how much distance is left in the track, from where you are. So I can use that information then to feed into our system to be able to know who's in first place and second and third and fourth place, and things like that. So that's all well and good, that this is set up. But when I first set this up, what we were doing was, like, if we look at these vehicles, so like if we're basically what we're doing is calculating which one of these nodes or these spline points that the vehicle was closest to, and then calculating the distance from that vehicle to that spline point, and then to the end of the track. So we kind of could know how much distance there is to the end of the track. The problem that we were running into was a couple problems. One was when you got to the end of the track, it wouldn't actually go down to zero. It wouldn't actually count you all the way down to zero. It get to like 1800 or 1200 or something like around that much. So like just less than 2000, but no less than 1000, and then it would actually jump back up to like the 80 something thousand units to go around the track. So the issue with that ended up being that we wouldn't know at the end of the track who was closest to the end, which is a problem. And then the other problem was if you had two vehicles sitting next to your point, and you had them kind of halfway in between, then what would happen was if you had one vehicle in front of the other one, then you could actually have it where the vehicle that was should technically be in second place actually had the lower distance, just because of how the math was working out and how we were picking which node to do the distance to, or which spline point node. So it just wasn't working. So I ended up redoing and revamping the system. And it was actually using some trigonometry, which I actually haven't had to use this kind of trigonometry in a while. So most of the trig I've ended up using were like Pythagorean's theorem, or being able to calculate the distance between two things, right? So basically calculating the sides of a triangle to be able to calculate vector distances and things like that. In this case, though, I'm actually solving for a triangle to be able to figure out the angle underneath. So what ends up happening is basically what I'm doing is checking if you have passed a certain node point, and if you have passed it, then I'm automatically doing your distance to the next node point, not necessarily the closest one. So it's the closest one until you've passed it, meaning that the angle underneath between you and that current node point you're closest to and the next node point, that basically that makes a triangle, right? So the triangle underneath, if it's less than 90 degrees, if it's less than 90 degrees, it means you've passed that point, right? So that's kind of how we're doing the system. So originally I'd kind of rigged up this system and wrote a lot of stuff out on paper. You can actually see my notes here, like my crazy math notes of trying to figure this out. So basically it came down to there was two ways to do this. There was the expensive way and the less expensive way. So the less expensive way involves just using a square root. So basically what I'm doing is solving a right triangle. So I'm figuring out if you are trying to think how to explain it. Basically, it's if you are level, like if you were even with the node point you're passing, if you're even with it or in front of it, then the angle underneath would be 90 degrees or less than 90 degrees. But instead of trying to solve for that angle, which includes doing like arc cosines, which is a little more expensive of an operation to do than square roots, if I recall correctly. But it also is a much more complicated calculation because there's a lot more stuff you have to kind of figure out. So what I'm doing is saying like, well, what's my distance from the vehicle to the next spawn point, and comparing that to the ideal distance if I was actually at 90 degrees. And if it's less than that, that means I'm less than 90 degrees because the angle for the triangle will be shorter, so this point here is going to be less than the ideal. So basically that's what I'm doing. But I'm in the middle of doing that system, so I had to leave off doing that system when I was last working on it. So that's what we'll be working on. And I'm trying to recall if I actually opened up Evernote. I did. So let's see. I need to go look at my notes about where I left off last time. Okay. Now I remember. I actually had to do more paper notes because I was doing a flow chart, which I've not done a flow chart in a while. I remember doing those in school because I was originally in school for computer science a long time ago, and I remember doing those there. So let's see. Okay, let's actually go look at our code here. So I'm still, excuse me, I'm using C++ code, but not entirely, because there's basically C++ code kind of fits in with Blueprint, so you end up using both all the time. So I can actually go into Blueprints, and I was looking at, I believe it was the game mode that was, yeah, here it is. So I only completed to get, okay, right. So I wanted this to compile so that I could actually check it into our source code. So I actually need to, I actually completed the graph prematurely. So yeah, squigglies everywhere. So you can see this is kind of, I kind of tried to clean this up as best as I could. But basically how this flowchart works is, well, this kind of goes by my flowchart. So basically when we get the distance to the end of the lap, we take the player's asking, get their world location, get the index for the closest spline point, which this is actually a C++ node. So if you go to code definition, this is actually C++ here. So in this header file, it was, yeah, get index for closest spline point. So in here we go. So yeah, here's getting the index for the closest spline point. So basically it's this giant for loop that's comparing distances and getting the size of these vectors, and setting the current size equal to a particular distance vector, and then checking if that's the lowest size or not. So basically we're checking like distances to all of the spline points, which we pass in here. We have it cached, or basically an array of spline point locations that are cached, and they're cached during. They're cached at event begin play, so they're actually cached at the beginning of the game. Okay, so getting that, and then okay, so we have these branches. So we're basically, if it matters if the closest spline point that we're to is the final spline point, because if it is, then we actually need to calculate the distances differently. So yeah, okay. So is the and then there's this function of is angle underneath vehicle less than 90 degrees. So, and that takes in some information that we have to calculate, which is the distance from the vehicle to the spline point. So that's the closest spline point, and the distance from the closest one to the next one, and the distance from the vehicle to the next spline point. So basically what I'm doing is getting all the angles to a triangle between the vehicle, the current spline point, and the next spline point. So getting that triangle, and then I can basically take that triangle, and I can then solve that triangle and be able to see, be able to basically solve that triangle to see, okay, is this going to be closer? Are you basically less than or greater than 90 degrees? Ooh, pardon me. You don't get much sleep when you're doing this work. Let me tell you, too much stuff to do. Okay, so now if we're at the last spline point, and this is and you are less than 90 degrees, then our remaining distance that we need to return is from the vehicle to the first spline point. So I think we have distance to. Okay, so yeah, so it needs to be the distance from the vehicle, which we have a reference here. Here's our world location. So basically we need our world location. And this needs to be, this is our vehicle's location. And we need to actually then subtract. I need to check this out. So we need our vehicle's location. So basically it's kind of something like this, where we get our vehicle's location, and we basically take the location of that last spline point or the first spline point, and subtract the location of the vehicle from it, and then we can get the distance of that. Okay, so now the vehicle, and I'm having to talk this out of my head to make sure that I'm doing this right. So now that we have the vehicle distance, now we need the location for the first spawn point. So we need to actually do the spline. Okay, track info, the spline point location, get. There we go. So that'll be the first spline point, which is 0. And this is an ordered array. So this is like from 0 to the end. We cache all of the locations. And the reason we're caching them is this is going to get pulled every frame. So if we didn't cache them, this location is actually in another blueprint. So they would have to then go and call a function to the other blueprint, pull the data in, but the data doesn't change from the start of the game because the map size doesn't change. So we can just pardon me, we can just cache that stuff. Okay, so that actually then we need to get the length, vector length, and that returns a float value. And then that float value will actually go, okay, I'm going to need a local variable now, and this will be distance to return. The reason I need a local variable is I need to basically set this to a value that we're going to return, and then just return that value. Because there's so many code paths here. There's a branch here, and then there's a branch here, and here. So there's actually 4 different ways to calculate the distance depending on the specific situation. So basically what I'm going to do is take this and set it to this. So that'll be the first thing to do. If it is the last spline point, then we need to calculate it that way, which I'm going to take this stuff and move it up. And then once that's calculated, then we need to actually go to the end, and then this actually needs to be that. Okay, so that's the first path. So that is if we are less than 90 degrees and the vehicle is past the closest. So okay, so this is if we're at the closest spline point and we're past. If we're at the last spline point, that's what this is. Last spline point less than 90 degrees. And that's what that is. So now we need to go at last spline point greater than 90 degrees. So what that is, okay, so what this is the distance would then be distance from the vehicle to the current spline point plus the distance from the final spline point to the first spline point. So now we need vehicle. So actually we've already calculated vehicle distance to closest spline point, which is this right here. This is the distance. So we need to take this and add it to, and this will be float plus float. So we've already calculated, and that's this calculation here, which is figuring out our location versus the current location versus the next one. Yeah, so that is distance from the vehicle to the current spline point, and then we need to do the distance. So basically we need to take this first spline point distance and basically kind of do the same thing. Vector minus vector. We need to then take these, which is the first spline point, and the current spline point location. So this is the, let's see, here's the current spline point's location. Because here's the index for closest spline point getting that location. So here's that location. And here. And then we need to get the length. And then we need to add these two. Then we need to basically add these two together. And then set this. that is that. Ooh, didn't mean to pull it that much. I always do that. I will grab the wrong thing. Okay, so this is if we are at the closest spline, if the closest spline point is the final spline point, then if the vehicle is not past it, then the distance is distance from the distance of the first spline point to the current one, which ends up being the last one. Then the vector length, which actually this is gonna not work all the time, because basically I'm saying like the closest one here, but this might actually break to be. Eventually, it'll jump to the closest one being the next one, and that would then be 0. So we'd have a point where we were at 0. So we need to actually. Let me actually make sure that I'm actually pulling the final one. So what I need to do is pull from here, get, and then actually also pull from here and do length. Minus 1. And we're doing length minus 1 because the length ends up being the total distance, or the total, which, so if you had like 10 things in an array, then the last one would be actually 9, because it goes from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, which is still 10, but yeah, and then that way we're definitely getting the last one, and we're not going off of that previous calculation. Okay, so that's that. So almost done. Next is if we aren't at the last spline point and our angle is past it, is less than 90 degrees, then we need to get the distance at the end of the track from the next spline point. So not the current one, but int plus. And basically we can just say int this plus 1. Now the reason this is working, if we just did this and we weren't already checking if we were at the end, then we could do an overrun on the array and basically do an array out of bounds. The reason that we don't have to worry about doing an array out of bounds in that case is we're already checking if we're at the last position. So if we aren't at the last position, then we're going down in here. So we can just add 1 to get the distance to the end of the track from that, and then we're going to add it to the distance, which we're going to add it to the vehicle's distance to that next spline point. So I need to get vehicle's distance. So I need to get the vehicle location. So it's going to be the vehicle's location. We'll kind of do this down here. So vehicle's location plus, or actually minus, the location of the next vector. So it's going to be this cached thing, and a get, and this value for that one. So that, getting the length, and then adding this into that right over here. I'm going to do that number, and then that is going to get stored in that, and then do that to there. Okay, and I can actually delete that comment now. Okay, so that's if we are past the spline point, then we need to go to the next one. If we aren't past the spline point, then we actually need to do the distance to the current, so it's the vehicle's current Well, actually, it's this right here, this vector length, which is the distance from the vehicle to the current point. We're actually going to set this to that. So this is already calculating the distance from the vehicle to the closest spline point. So that's actually what gets set if we aren't past the spline point, then it's just distance to the closest one, plus, actually, I'm doing this wrong, plus, I need to take this function and copy it. So it is from the current spline point, which is this value. So this plus this, and that does that. So this actually needs to go here first, then here, then that goes to the end. And that actually should be it. We should have 4, yeah, 1, 2, 3, 4 things through here. So let's check this. So is the distance to the closest spline point, is closest spline point the final spline point? No, it's not. Are we past the spline point? No, we're not. Then we need to get the distance from the current spline point. Oh wait, I need to send that over to the track definition. So distance to the current spline point, which again is already calculated back here. Then we're taking that distance remaining plus this other distance, which is the distance from the closest spline point to the vehicle, and then adding those together, and then ends up being the distance returned. There we go. And I want to check this bottom one more time. So if we're not at the last spline and we are less than 40, then we are past that closest spline, then we're going to calculate the distance from the next one to the end of the track, and then also from the vehicle to that next one, add them together. And there you go. So compile, save. And then our vehicle blueprint should be asking, which actually go to game. Where's our proto vehicle? And proto vehicle. And this should be asking inside, yeah, inside event tick, the distance, get player distance to end of lap. And that's what we were just working on, was this function. And then distance to end of lap. Okay, so now we can actually test this out. Hopefully this works. New editor window. So it should see a giant stream of numbers. Okay. And you can, I don't know if you can see really well, but it is counting down. We're at 72,000 now, 71,000. And let's see here. Oop, gonna spin out. I think we've also adjusted the handling of the vehicles since last week. Last week's stream. Alright, down to 28,000. And jumping over here. I'm going to put the brakes on. I fell off. Okay, we'll try this again. I'm trying to play on the keyboard, and I haven't played on the keyboard in a while. I've usually done... well, that was kind of cool. I've usually done the gamepad. I'm actually doing alright. Brakes. Nope. Aw. Yeah, I'm just going to use the gamepad because I'm terrible on the keyboard. Let me just plug my gamepad in. Okay, let's actually try this again. There we go. Maybe we'll do a little better. Yeah, I'm a little better at counter steering on the gamepad. And am I gonna make the jump? I made it. Cool. I think I need to adjust this this last jump, but we'll get there. Okay, we're down to 12,000. All right. Let's see if we're going to. Okay, this is where we're having issues last time. So 3,000, 2,000, 1,000. Yeah, see, it goes from 1,000 back up to 90. So, yeah, we're at 90,188. Now, when I back up a little bit, I'm now at 1,100. So it comes down to this like last section. Oh, I remember what's happening now. When I'm less than 90, I'm hitting that first one, but I'm also adding the distance to the rest of the track. And I don't need to do that. So that's what's happening here. Is like once I get, like, you can kind of see where it changes. I'm at 1,000 right now, so I'm probably past 90 degrees on the last point, which means I'm going from myself to the next point. But then as soon as I get to the point where I would actually switch over to be closest to the next one, like now that I'm actually past 90 degrees, what it's doing is me to the next one plus the entire track. So let's fix that. Okay, so basically what it is I'm at the last spline point, yes. Am I past the spline point? Yes. Then it needs to just be this, me to the distance here. What's really trouble is I can't, like, break this easily because it's running every frame. Let's see. It just gets to the point of, oh wait, the closest one. Oh, I figured it out. So what's happening is, eventually we get from the closest point being, the final one to the closest point being the next one, and to the closest point being the next one, or being the final, but we haven't actually crossed the finish line yet. So basically, I think there needs to be some kind of thing to know whether or not I've crossed the finish line or not, and maybe feed that in via a bool. I guess I could feed that in from the vehicle and say, so you have to think about this out loud. If I feed it in from the vehicle, then a Boolean value could be used when we are not at the last point. Excuse me, because what's happening is, like, eventually our closest one will not be the last point, and then if we're not at the last point, then it's going down and saying, well, am I greater than 90 degrees? Yes. Then it's just we're adding the distance to the rest of the track to that at the first point, which is basically we don't want to do. I guess what I need to do is, if I'm at the first point, if I'm closest to the first point and I'm less than 90 degrees, pardon me. If I'm at the first point and I'm greater than 90 degrees, so am I at the last point? Yes or no? If I'm not at the last point, then I need to actually check in here. I need to have a branch if I'm at the first point. Okay, so am I at is this equal to 0? And then if it's not equal to 0, I can keep going. I can keep doing what I've been doing. But if it is equal to 0, then it just needs to be Um, then it just needs to be the vehicle distance to the final point, to the 0 point. So it needs to be this plus this plus. So basically, just the vehicle's. Oh, it's not even that. It's the vehicle's. Wait, stop. It's the vehicle's location, which is this, minus the location of the first point. So it's going to be these. I'll have to admit, this is one of the crazier, more like noodly blueprints I've ever made. Okay, so that'll be the vector length from the vehicle location to the location of the first one, and I need to set this. And there. Okay, now let's try this. It's still jumping. Still jumping. So when I play, though, is it at the 90,000 value? Yeah, so what I'm actually might do, as annoying as it's going to be, I'm going to add a breakpoint right here and play. Okay, so I'm going to step through this 55. So we're at so what's the length of this? 57. So we're actually at the second to last one. Wait, why is it doing that? So there are 57. So we're at 55. So we're not at the final spline point. We're not at the first spline point. So is the vehicle past the closest spline point? I am past the closest spline point. So now I'm getting distance to the end of the track. And exporting it. Okay, so I'm getting distance to the end of the track, which is from 56, spline length. Okay, so we're figuring this out here. Then we're setting it to 90,000. And we're printing it. Okay, let's just resume. Okay, stop. So, alright, well I think I'm spawning in this same space here. Oh, wait. Disable breakpoint. I'm starting in this... Yeah, I'm starting in the same place. Okay. So I'm starting here. So I am... So it should just be from me to the end. But I'm closest to this one, though. So I think maybe I'm off on how many things there are. I don't want to have to count them. Maybe I'm off on the number of... Yeah. So, fun times. I'm going to have to look through this again. Well, let's turn this breakpoint back on. Okay, so there's 57 points in the array, and we are closest to number 55. I'm actually gonna count these, cause I don't know. Well, maybe I won't count them. Maybe I'll do this. What if I, just for kicks, move this way back here, and I click play. Nope, stop. Disable breakpoint, play. I'm getting smaller numbers. Whoa, that's weirdness. We're going from 2,000 to 90,000 to just a couple hundred. So maybe what I need to do is like delete these last two so they're not so close together. See, now it's jumping up to like 3,000, 90,000. And then as soon as I cross that threshold of being like being closer to one versus the other. So like now it's going through and saying like I am adding the entire rest of the track. But then I'm not, because I have 3,000 right here. And it's basically when I cross this last point. Because now is like from me to that spline point. I'm pointing at the screen, but that spline point in the middle of the screen, and then I pass that spline point, and it's going to like the entirety of the track. And then it says, oh, I'm actually closer to this endpoint now. So it's like, this is where the problem is right here. So what happens when I actually just play? I'm at like 600. Okay. Let's add another point in, like right there. Yeah, it's still that problem. Still getting down to like, but then it goes back up again. So like here's like 80 something thousand, and then it goes down to like, oh, 500 now because I'm still closer to the first one. Hmm. It's close. Okay, I'm just labeling this so I know what it is. Okay, yeah. I think I don't need this any. This is like getting me closer if it's the first spline point, but then I also need to know like, have I started a new lap? Um, hmm. Well, this is gonna take some more thought, definitely. Okay. If I am the closest spline point, if the first one is the closest, then I actually need to do the 90-degree checking again. That if I'm less than 90 degrees, I need to go into the next one. Okay. So if I'm less than 90, so basically I need to check this. So I need another branch if I'm closer to the first one. I need to be checking this, which these values should be fine because I'm not changing. I'm going off of this, whether or not it's the first one, so that shouldn't change in that time. So I can still use that. So am I less than 90 degrees? If I am not less than 90 degrees, then I can do what I've been doing. If I am less than 90 degrees, then I need to actually go to the next spline point, which actually would be right into where that true is, right here. Because basically what this is asking again, am I underneath this 90 degrees for the next spline point, whatever. So basically it's like I need to look at the next spline point, which is this. So basically I'm like interrupting this false and saying, well, you know, if it's false, then I'm doing the true false here. But then if I am at the first spline point and I am less than 90 degrees to the current spline point, the current closest one. So it's like if the closest one is the first one and I am less than 90 degrees to it, then I need to be looking at the distance to the next spline point. But if I'm not, then I need to look at the distance just to the end. Okay, that actually might fix that. Okay, let's see. Maybe. Nope. Let's see, mate. It's making it worse. It's still adding the entire. Okay. It's still adding the entire distance at the end. I think it's jumping to the next one when it needs to be. I need to be past 90 to that first one. Well, I got it closer to what I'm wanting, but still a little buggy. But it's closer to what we're wanting. But as you can see, it's kind of a complex, noodly system. So I may end up leaving this for now and working on some of the other systems, because I may actually be able to pull data in from some of the other systems to make this work better. Because basically it's, I think that the problem comes down into, like, when I get close enough to the first spline point to actually jump to that being the closest one, then I'm not calculating that correctly. I'm basically calculating to that point plus the rest of the track loop, um, which is not what I want. So we're at about 52 minutes for the stream, so I'm actually going to cut it a little short today, um, because of some other scheduling conflicts that we have coming up. But yeah, so we saw a little bit of some vector math, some scripting. Um, so probably actually really quick, just because it's kind of I like talking about it and it's fun. I'll talk a little bit about the C++ stuff. Um, so basically, C++ and Unreal Engine is really macro heavy. So we'll actually take a look at this one. This is angle underneath less than 90 degrees. So if I right click and go to code definition, so we'll jump over here. So we have this function that's defined. It's a static function, and the reason it's a static function is this class is a blueprint function library. So basically this is just a collection of static functions that you can just call to do some kind of work. And the cool thing with this is these are all const functions, which means that the values that are passed in are actually not changed. They're just used to do some calculations and then spit out a value. So in this case, we're spitting out a Boolean value, which is true, false. But what I said, it's very macro heavy, is that we have this U function macro, and what this does is defines what this function looks like. So where I have marked as blueprint pure, and what that means is that this is a function that can be called inside Blueprint, and it's a quote-unquote pure function, meaning that it doesn't actually modify any state data. So it's not going to change any variable data for the blueprint that it's in. And that's why these are also labeled as const, these the data that's being passed in, because it's not being changed, it's just being used to do some calculations. Then we set the category here, which is pole position math. So if I were to go back in here, oh, it's in the middle of an autosave. Waiting for that to finish. Cool. So if I were to right click in here and do call function, or actually not call function, here we go, pole position math. So this here has the actual functions that I'm looking for, and this pole position math is actually pulled from this category label. And then the reason that these are pole position math are green is that these are functions that are called that don't have inputs and outputs. So if you look at, say, this function over here where we're getting the distance to the end of the track, you can see that this has to be wired up as nodes here, right? And that's because this isn't a pure function. I could set it up that way if I wanted to. I would just have to go and edit this function definition, which was what? Get distance to end of track from spline point. And actually, I don't think I can mark this as pure because it is a interface. I don't think I don't know if you can do that with interfaces. That's interesting. So this is inside track definition. Get end of track. Oh, I can mark it as pure. Sweet. Let me see if that actually does what I think it's gonna do. So now if I go back to the game mode and I compile. That's interesting. So if I were to say let's see, interface messages, track definition, get distance to end of track, spline point. Nope. Okay, well, it's still pure because I'm not actually modifying anything, but that's interesting that you can't do that. Oh, I can force it to be a pure function. Oh, okay, well, let's not do that then. Let's leave it like that. So actually, BP track definition is now modified, and I don't want it to be modified. So go to blueprints, track definition, revert. And save the race mode. Okay, yeah. So it being a pure function means that there's no. I can basically put it wherever I want to, and it gets called in line when we're pulling in data, which works like this. So when we have a branch and the branch is requesting this condition, it'll go back and say, okay, call this function and pull in all this data, and it'll calculate all these data out to get these vector lengths, and then place it in and call this function. But it doesn't have to actually be in line with any of these white wires, which helps to kind of just make this a little cleaner, a little neater. I don't have to worry about branching off and calling something and back. So I like doing that. So if you go to the definition of this function, which is this is angle less than, so basically what we're doing is figuring out the ideal distance by doing basically Pythagorean's theorem here, and that we're assuming a 90-degree corner underneath, and then we're figuring out what the hypotenuse of the triangle would be from the vehicle to the next spline point. We're figuring out what that hypotenuse would be and the actual length of it based on ideally if it was actually a 90-degree corner, based on the distance of the vehicle to the point and then from the point to the next point. So we would figure out, okay, if that angle was 90 degrees, it would be this length. And then we say, okay, is that length less than or equal to the ideal length? And that's how we're calculating whether or not we're less than 90 or equal to 90. Because if we're more than 90, then the hypotenuse would be longer than the ideal at 90. And if it's less than or equal to it, then that angle underneath is less. So that way, basically, we're just having to do a square root and not having to worry about doing any cosines or arc cosines or anything like that to solve that angle underneath. And then we return if it returns false if it's not, and then if it is less than or equal to the ideal, then we are not less than 90 and it returns true. So pretty straightforward. And theoretically, you could do this inside of Blueprint. The reason I decided to do this in C++ is that it does do a square root operation, and it's doing it every frame. And those are the two big things. It's a slightly more expensive math calculation doing square roots, and it's the same with this up here. This get index for closest track spline point. It's a for loop, so it needs to iterate through this. And we had like 50 some spline points we had to iterate through. So yes, we could do that in Blueprint, but because it's running every single frame, and because this is literally just calculating things to say, okay, this is the index, or this is the yes or no for this boolean return, it's simpler and faster to actually go do and write this in code, so that when you go and call these functions, it's actually C++ code that's being called, and that's faster than Blueprint. I've heard up to 10 times faster, I've heard. So if this was like a single time I was calculating this, like once, I may as well do it in Blueprint. But because it's being run every single frame, and even then you can see how complex this is, so we would have to be taking these functions and making their own functions, and it would just kind of spiral out into this huge thing. So that'll actually be it for the stream. So a little bit of C++ coding explanation here, a little bit. So yeah, the system's a little better. It's less buggy than it was, but probably what I'm going to end up doing, like I said, is leaving this, moving on to another system, and probably the lap time system next, because I'm thinking that I could probably pull some data in to say, what lap am I on when I start calculating these distances, and then calculating if I'm on lap 1 or lap 2, and kind of calculating that. So probably what I'll end up doing is, for that last spline point, calculating the additional distance, and probably saying, okay, only calculate the additional distance to the rest of the track if I'm actually on the if I'm actually on the current lap still. So probably what I'll end up doing is, with a lap system, I'll probably pass in the lap time. And actually, I'm going to write this down because now I'm actually thinking through this. Where's my pen? Oh, I've lost my pen. Hang on, I'm going to move my camera. You can see my nice Mythbusters shirt that I got when I went to the Mythbusters exhibit in Colorado. That was pretty awesome, being able to see all those artifacts. Which is kind of odd to think that they're artifacts from the show, because I think artifacts, like Indiana Jones, right? Or like Tomb Raider, and you're like going to get an artifact, or Uncharted, which are kind of all stemming from the same like Pulp Fiction stuff from I think the 20s or the 30s. I don't recall when that stuff was popular. But anyways, yeah, so basically I can only calculate the remaining node distance, like the remaining node distance. Yeah, only calculate remaining node distance if on same lap as last frame. So basically then, okay, that kind of solves the problem. So what that'll do is when I finish doing the system for doing the laps, then I can basically pass in the lap number. Pass in the lap number, and then check compare to last frame, and if it's the same lap number, then what I can do is then like, okay, it's the same as the last one, then we'll calculate all the way to the end, and we'll only calculate to that end spline point, and then when we get to the end, so that we don't get this weird like additional adding, we won't add that stuff. Like basically we like won't add it anymore when we get to the like the last spline point or the last couple. We won't add that whole distance on anymore until the lap number changes, which that'll change when we cross the finish line. So hopefully I can then take some data from the other systems to give more context to where we are and what we're doing, in terms of like where all the vehicles are and what they're doing to kind of make the system work a little better. Lastly, I'm going to compile and save everything so that, I don't lose anything that I've worked on. Like the last stream, I think it was the last one where I somehow magically lost all my spline data. That wasn't fun. So while that's saving, I'm going to go ahead and pop over to this here. So again, want to ask that if you are enjoying live streams, you like taking a look at them, and either here on Twitch or if you're watching on YouTube in an archive, it's super helpful to us to follow us on Twitter, like our Facebook page. We're actually really close to 500 likes on our Facebook page, so if you would help out to kind of push us over getting 500 likes, that'd be amazing. And you can find more information about the game at nacellegames.com/RoseRacer. And also subscribe if you're on YouTube, or follow us here on Twitch. And that way you'll be notified when there's a new live stream or when there's a new video posted to YouTube. So thanks so much for joining us this morning, and we'll see you next week.